Okay, 9 o'clock. Good morning. This is Steve Krpata, Industrial Sales Manager from Pure Air Filtration in Atlanta, Georgia. We're going to do our webinar this morning on room sealing in pulp and paper mills. Let's see. So this is the table of contents of describing what we're going to go over. We'll do first an introduction of pure air filtration, segueing into paper mills, specifically the benefits of room sealing. We'll give examples of room sealing and what pure air does differently than the competition. First of all, on that particular issue, we do actually provide room sealing and hands-on help on fixing your problems and creating solutions that will give you quality air. I don't think any of our competitors really provide that. And if they do, they might try and sub that out. So we have actual people who have done this work for years. And so that's a big difference. We can help you with any situation you find. So as far as Pure Air itself is concerned, as a company, Pure Air Filtration, we have a manufacturing facility in Atlanta, Georgia. We have been established 20 years ago. There are more than 45 employees, and we have sales to over 50 countries around the world. And we are actually taking care of all of the, actually our own manufacturing ourselves here, whereas most of our competition subs things out, brings it in. And so we are a single source manufacturer. So that does set us apart from the competition. We are ISO 9001 certified. We're going to concentrate on one particular market, but we'll show in a little while that we are in really multiple markets with multiple applications, which helps us provide a wide range of solutions to whatever problems you have that come up. And we can, because we are our own manufacturer, we have customizable solutions and engineer products for your solutions, which helps in unique situations. Like we can change the dimensions slightly if we needed to, in order to fit a piece of equipment somewhere. We have on numerous occasions had to make changes to it or change motor sizes or whatever needs to be done to actually fix your particular problem. We have hundreds of absorbent medias that we have available, which are geared specifically for different solutions to different problems. And this presentation will focus on one that's particularly been developed for the pulp and paper industry, but there are wide ranges and sometimes there are unique applications, even in pulp and paper mills, that would require a slightly different solution than the norm. We are able to monitor the absorbance consumption. There's a big question. I know we get lots of times in the field with customers, well, how do I know what the status is of the media? Most of our competition wants you to change it out on the basis of the calendar, which is almost always going to be wrong. You either will be leaving it in longer than it needs to be, which means you're not protecting your electronics and subjecting that to failure, or you don't do that, and you are basically taking and replacing media that's still good and could last longer, and allocate those rare resources to something else that would be more uh, important at the particular moment. So the monitoring of the absorbent consumption and telling you what's the remaining life is critical. And there's a lot of different ways that we do that. We'll get into that a little bit more. We have monitoring systems. Some are automatic, some are manual. We have a manual bed rod, which is sort of like a dipstick in your car. It can be put onto the side of a deep bed system and pulled in and out, and tell you, based on the changes in color, whether or not there's how much remaining life there is to that particular bed of media. We have in the particular media that we talk about for pulp and paper mills, there's people, and it has that purple potassium permanganate in it, and that turns brown as it gets used up. So you can tell by color changes. And we can take samples of media and send that to our lab. We have an in-house lab that can test the media and tell us what the remaining life is. That particular one can be a little sketchy if the sampling protocols aren't uniform from sample to sample, but it can give you at least an indication of what remaining life you do have, which is critical to changing out and getting the most money out of your media expenditures. So this shows the various industries and applications that we are in. We have odor and environmental emission controls, which is basically things like water treatment plants and that sort of thing. We have indoor air quality for things like airports, museums, restaurants, where you're worried about that. Emergency gas scrubbers. If you have there's a large, say, chlorine leak, we have equipment that will basically suck that up and mitigate that toxic gas. But really what we're talking about primarily this morning is the industrial applications of the protection of mission critical electronics from failure. If you allow the electronics to be corroded, then what will happen is you'll have unplanned failures, which will lead generally to unplanned outages. And so now we're going to focus primarily on the paper mills and try and get the focus on that more narrowly instead of our global applications. In this particular slide, it's basically talking that the byproducts of the paper production process produces various gases, some of which have foul odors, some of which are just harmful to electronics and are corrosive, such as hydrogen sulfides, sulfur oxides, and nitrogen oxides. And what this is showing here is the corrosion examples of electronic equipment. On the left is a piece of equipment that hasn't been protected and is doing corrosion. And the one on the right is a piece of equipment that is not being corroded and will not be subject to the same failures that the electronic equipment that's subjected to the corrosive gases will have. And when you have the corrosion with the electronics, as many of you are aware, that will eventually lead to premature failures of the equipment. And generally, it doesn't happen at the best time. And if it's in a critical component, it could put down the mill. A lot of these boards and pieces of equipment that corrode these days are very expensive. It's not unusual for them to be a couple $100,000 to replace. But what's even more expensive is what happens when it puts down your production process, and the lost revenues generally can be hundreds of thousands of dollars an hour. And if it stretches on, the longer it stretches on, it could easily end up costing you millions of dollars, which you're not going to get back. And that goes right off of the bottom line. And the components of corrosion, there's basically are four legs to the stool of corrosion. There is corrosive chemicals in the air, there are particulates, there's temperature, and there's humidity. So all four of those factors come into play, and we consider those in providing our solutions to your problems. And eliminating the causes of corrosion basically increases your reliability, which increases your profitability by not having unplanned outages and making the revenue that otherwise gets lost. And a lot of what we'll hear talk about today is basically trying to get your air into a G1 status, which is an ISA designation. ISA was basically created by the electronic equipment manufacturers to grade air G1, G2, G3, GX, because they were seeing a lot of failures and warranty applications. And what that does is if you don't have G1 air, they basically can walk away from whatever warranties you think you have on your equipment. And so you don't want to do that. So we want to help you fix it, and we can make sure that you consistently receive G1 air in your applications. One of the ways we can do that is through supplying equipment. And this slide shows some of the equipment that is used particularly in pulp and paper mills. On the left-hand side is a vertical bed system that has been designed. This is showing it in stainless steel. It's been designed specifically for the harsh environments that are found in pulp and paper mills. And this is a rock solid deep bed system that has an airflow capacity between 300 and 5,600 CFM, and is used to protect your electronics in mission critical electronics and for border control also. And so that's a flow up system. The next one in the middle, side access housing, is basically a horizontal application, and the air flows through the system, and it can have several banks of these media modules that are in there. They generally have to be changed out more often than a deep bed system, but these provide a great deal of flow. They're very compact, and they can have air flows between 500 and 40,000 CFM, which gives you a nice broad range to work with. And like I said, you can add multiple banks of in there for different medias or for the same media to kind of customize your application. And then another group that we have, the package filter units, PFUs, are very popular. We try to have some of these in stock so that they can be turned around pretty quickly. And what these do are vertical flows. They can either be recirculating or pressurization. And we have basically 5 different models. 3 of them are stationary, the 1000, 2000, and 3000 models. And we have some that are actually more easily portable to different rooms. And those are smaller versions. And the airflow capacities of all these are somewhere between 250 CFM and 3000 CFM, which gives you a pretty broad range. The portable ones are used by many people temporarily when we're trying to craft a long-term solution. You can roll those into problem areas right away and get immediate coverage of your air. And then once the final solution to the whole thing is crafted and in place, then you can move that to your next critical room, and that will help you mitigate your problems faster. And then we also have different medias and monitoring solutions which can be applied to your applications. Usually, lots of times what will happen is on the right-hand side, these corrosivity test kits, which sometimes people call coupons, are deployed first to give a baseline indication of the grade for the various rooms. It helps prioritize which rooms to attack first and which ones need perhaps to be looked at for immediate media changeouts. So these are placed in the rooms, the test areas for 30 days. This is all based, again, on the ISA standards. So we have a silver and copper coupon on the kit that is placed for 30 days and then comes back, gets sent to our lab for testing, and we will determine from that the quantities of different corrosive gases that were found in that particular space, and then give it a grade, G1, G2, G3, GX. And the grade of each of the different metals, the copper and the silver, are not usually the same when they're done, but the grade for the room would be the worst of the two. So, for example, it might be that your copper strip is coming back with a grade of G2, and the silver is a grade of G3. That room would be classified as a G3 room. And when you have G3 and GXs, you want to really hop on those immediately and to mitigate those problems as quickly as possible, because your goal is G1 air, but at least no worse than G2. The monitor in the center, the ECM, ours right now, we have an ECM V2, which is what's displayed there. Basically in real time, tests and reports on 5 different factors in real time that are present in whatever room that it's placed in. So it will show you what the corrosion factor is and give it a grade, G1, G2, G3, GX. For copper, the top sensor there is a copper sensor, and the bottom sensor is a silver sensor. So that's consistent with the ISA standards. It also will report on temperature and humidity. If you'll recall, those are two of the components, or of the two of the four legs of the corrosion stool, if you will. So we want to try and keep the temperature around 72 degrees Fahrenheit and the relative humidity around 45%. Then the fifth element that this device reports on is room pressure. So that would be the only thing you'd have to, when this is installed, you'd have to run a reference tube outside the space to give you a differential pressure reading. And people have different target pressures that they're trying to get. And whatever that is, I'll report back on these get sampled, and they can report back to a central database. Many people use Pi systems over using a Modbus protocol is what's built in here, and reports back, and you can maintain and see what how the room is performing in real time. If, for example, the room pressure dropped out all of a sudden, somebody leaves the door open or turns the equipment off, you can send alarms to appropriate people based on that information, and make sure that it doesn't stay in that condition for a long period of time. And then the PP blend media is something that's been designed specifically for pulp and paper mills, and it's a 50% blend of pure 8 potassium permanganate in alumina balls and the sulfosorb 2, which between the two offer a wider range of gas, corrosive gas removal from the air as it goes through there. Which is a lot broader than just either one alone. Lots of mills have just used the carbon media in various forms to remove the gases, and it's just not as vibrant a solution as the PP blend is. And the PP blend tends to last longer and all that, and generally is less expensive than the competitors' version of the medias. And it can be UL certified, so it's not a fire hazard. Carbon media in and of itself, if you look at the SDS, will be on there as a fire hazard. It's a lot like a charcoal grill, especially with chemicals added to it. It creates heat as a byproduct, and if the airflow isn't managed properly, you can ignite it basically and have a charcoal bed fire, which we've had help people have had problems where the scrubbers have caught on fire, they've shut down the mill and all that sort of thing. And that's fire is something you don't want to have in a pulp and paper mill. So this will help mitigate that. And the purple, as I mentioned before, in the PP blend has a color change to it that tells you that it's being used up, and and it gets used up in the direction of airflow. So in that industrial VBS we showed earlier has a bottom-up airflow. The bottom media of the media bed would get used up first, and the top would get used up last. So knowing that, if you take out the samples throughout that bed, you can see if it's still viable or not. And then it's the same thing with each of those purple balls itself. It'll get used up from the outside in. So if you crush one and it's purple still on the inside, then it still has life. But if it's brown all the way through, then it's totally used up. So that's one of the ways that you can tell yourself if the media is used up or not and needs to be changed out. Then one of the things that we provide that none of our competition provides is room sealing. We is one of the products that we or services that we provide that helps you get to your G1 air in the most economic way possible. What the benefits of sealing a room first is that what you're doing with the room or your space, I would rather call it space, that you're trying to pressurize or purify the air in there is you want to do it in the most efficient manner possible. If you have a normal room before it's sealed, it usually has lots of bypasses, lots of holes in it, and a well-sealed room is just a lot more efficient and effective in keeping the good air in and the bad air out. It's you don't have those holes, letting things into the room that you have to add more air to, basically, to mitigate. And whatever your target parameters are for air quality or air room pressure or any of that sort of thing, the better the sealing of the room, the smaller the units are that you will need to achieve those parameters. And what that means is a lower capital cost for your air purification units. That means that you'll have smaller requirements for any air handling units, because one of the things, especially if you're pressurizing the room, the only way you pressurize a room is by bringing in outside air from the space. And that outside air will have two of the problems with contamination, which would be potentially heat and humidity. And that has to be treated one way or another to make sure that your air in the room is at its maximum performance. So when you have less air, let me put it another way, the only way you get more pressure is whatever the quality of the room is by adding more air from the outside. And if you are able to achieve the same result with less air because it's a more sound room, then you don't have the additional air for the air handlers to condition. So what we would do is seal the room, and it would result in capital cost reductions for both the APUs and the air handler units, which then translates into more efficient equipment production or operation and lower operating costs over the life of the system. And these systems, once they're installed, should be able to last for years and years and years. And what we do in terms of the process of the room sealing, it starts out by trying to define what's the space that we're dealing with. And that sounds easy enough, but sometimes it's a little confusing because it can be more than one room. Lots of times you say, well, we got to fix this room. But many times you have an equipment room, an electrical room, but attached to that, either physically directly attached to that or which makes it part of the space, is an equipment room. And that has the air handlers in it and things like that. So that they become the same controlled space. And what we have to do is treat that controlled space as common areas for purposes of room sealing. And they don't have to be contiguous rooms. If they're connecting through ductwork, that can make rooms that are detached part of the same controlled space. So sometimes it gets to be a little uh, trickier than you might think at first blush in deciding what is the controlled space that has to be addressed to begin with. And then we would basically reach out to find and create in that space a barrier around it and figure out what is the contiguous uh, envelope that we are trying to uh, provide for that space. And you want it basically to be the best way is to have it all on the inside, all of it to be contiguous, not to be moving in and out between inside the room and outside the room, because that makes it a lot more difficult to take care of. And then once you figure that out, what theoretically is the space, then we would look for any openings or penetrations in that. And that is another one of those things that seems like it's simple enough on the face of it, but it gets to be a little tricky in application in the real world. We would so we would go through looking at the obvious things first, like you look at holes where there might be a cable tray, or you look at things where there might be that you can see, light coming in from the outside that are just plain holes in the walls and things like that. You would fix all those. And what we do is we use fire rated materials for those, because you don't want it to, if there is a fire, you don't want the material that you use adding to the fire. You don't want it to be fuel for the fire. A lot of times people don't pay attention to that. You see that in rooms all the time where they've used great stuff for silicone caulks, and all that stuff has petroleum in it, and it would add to a fire if there was a fire. So that's the best practice, is to use fire rated caulks and foams and materials to do the sealing. And there's all grades of material we have to use depending on the particular application. And another area that is often overlooked, the material that's used to create rooms makes a big difference as to how well they can be sealed. Brick and block and concrete are always the best, and you can make very sound rooms or spaces by using those materials. But one of the things that happens with block is that it's very porous. If you were to fill up, they have cells in those blocks, masonry blocks. And if you were to pour water in it, eventually you would see the water leaching out because it's porous. So one of the things, if you do have a room that is made of block, one of the first things you'd want to do is to paint that to seal it. It's one of the simplest, cheapest ways of sealing a room. Depending on what kind of atmosphere is outside the room, all that would tend to filter through the pores in the blocks and come into the space. We ourselves are not really painters, but you get a painter to come in and put a good coat of paint on that block, and you go a long way towards improving the room. And so, and then the fourth thing that we do in terms of our process is, once we've gone through, we've sealed everything that we think that there is, and I'll talk about some of the other areas where they're in a minute, in terms of where there might be things other than we've talked about that are a little trickier to find. But at the end of the process, once we've think we've completed the room, then we perform a room integrity test, a blower door test, to validate the space and provide data metrics on how that performs, which can be used for sizing any equipment precisely, and not just guessing using rules of thumb as to what might be needed for that space, which again reduces your costs. So as we talk about, some of the penetration, some of the bypasses are easier to see than others. You have a picture, a photo here that shows a hole in the side of a wall underneath a raised floor probably in a rack room somewhere. That's a hole in the wall, and that needs to be fixed. And the people would probably see that one because part of it is over the top of the floor. If it was all underneath the floor, some people don't pick up those tiles and look at that. We know enough to know to look under those floors and pick up those tiles and search through all that stuff. The same thing with ceiling tiles. Ceiling tiles hide a lot of ills up above those, and you have to pop those up and look at that. And then there are some of the other things that people that are missed commonly are on the roof wall seams for a lot of the rooms. That's pretty typically a bypass, especially on the ends of the roof that have the stiffening ridges. Those indentations on this that are created by the stiffening ridges aren't usually are a bypass to the outside and need to be sealed if you want to basically have a good room sealing job. The other thing are conduits. Where conduits come into the room, unlike a straight cable tray, people look at those and kind of blow them off. They might, if they do look at them in any detail, they might, a lot of other people that we've seen their work sealing rooms, they might seal or caulk around the outside of the conduit, but then almost always they forget about the inside of the conduit. Well, that's a big highway generally going directly into your electrical equipment, bringing the contaminated air from the outside directly onto your equipment. It doesn't get a chance to be filtered first, and that's a huge problem. So you want to seal inside that also and stop that air from coming in. But then even if you do that, what I've seen some people make mistakes by trying to do things the easy way, and they might put some kind of caulk or duct seal or something at the end of the conduit that's in the equipment. But one of the things that happens there is, again, the outside ambient condition for these rooms generally is hot, humid, and plus has the contaminated gases and particulates, and so in that conduit would be warm, moist air. When it comes into that conditioned space, it's going to condense, and those pipes, those conduits will fill up with water, and then you can have 500 or 1,000 gallons of water when it pops that seal at the end of the conduit dump into your electrical cabinet, which water and electronics don't go well together, and it'll basically blow out your cabinet. So that needs to be sealed back closer to the wall, and so that problem doesn't happen. Some other areas are whether or not where the conduits come from. The ones you have to worry about are the ones that come outside of the defined space, and do they come up into the cabinets from below? You don't necessarily see those unless you drop access panels and look for them. So you have to know enough. So it could be kind of hidden that way. And then doors are another major area that have huge bypasses. An unsealed door without sweeps, it's not unusual when we test it for each one to bypass a couple hundred CFM of air. And we can test that because we can, by taping the doors off, we can simulate whether, good seals and good sweeps on the door. And testing them taped and untaped will give us exactly how much air is being lost through the doors. Let's see. Then let's say light switches and outlets can be a problem, especially if there's sheetrock. Sheetrock rooms are terrible because they usually hide a lot of sins, and some of it on light switches and duplex outlets can be a way for outside air to bypass into the space. If they're surface mounted, it's not usually as big a deal. You don't have to really worry about that so much. But in that other case, you do have to worry about switches and outlets. So these are some photos, before and after photos of sealing different places. The one that set on the left was in the prior slide also. And, we basically cleaned up the spot and seal it off from the outside. The other one is some cables running out of the space, and you had a lot of bypasses in the cables themselves. We would use foam in that cable bundle to seal the inside of that from bypassing air, and then seal around the outside of that whole area there that where the cables are going out. So then you have a complete seal and no air flowing in through there. So we, as a standard practice, do perform room integrity tests. We have an idea of we know what your target is for room pressurization, all that. We would check different volumes of air to see what pressures are needed to, what flow of air is needed to develop each pressure. And that helps us do a chart to figure out the validity of the data that we have. And if it's within certain established parameters, then we feel that we've sealed the room well. You're not going to have it perfectly hermetically sealed. There's always some air flow in there, and it's not unusual, for example, for a sealed room to have 2 to 3 air changes an hour based on the normal airflows that will get into the space. And so if it gets to that point, then that's pretty good, and we can say that job well done. But if it doesn't test out that way, and on occasion there are, even for experienced crews like ours, there are things that are hidden. Like I said, if there's sheetrock walls and different construction things, it gets to be trickier trying to find things, and we may have to use other methods to do that. So we may have to, use smoke pencils to, when we have the board on, the room is pressurized, to try and find where the particular leaks are. Then we can seal that, go back, do another room integrity test, and know that we have found all the problems and have gotten them sealed. And we do that for ourselves, and on occasion people ask us to do that to help them in their efforts to seal the rooms. Not everybody does that. Most people don't do room integrity tests because they don't know how, they don't have the equipment, don't want to do it, don't really care. but we think that's critical. Here's another example of, we talked about doors before. On the left-hand side, you can see that white strip around the door. Before that was installed, you could see through the door jamb light coming in from the outside. So light coming in, so it shows air coming in. So we seal that, and that had seals on the doors. You can sort of see that there, those silver highlights from the shining of the light that's on that door. So it did have seals on it. I'm not sure if it had sweeps on it, but the door jamb itself was a bypass, so that got fixed. And then over the picture on the right is showing in progress cable tray where some of the there's like metal strips and things like that used there to block up some of the space, and so we've started sealing that up. And then what will happen, the next step on here would be probably some foam in between those cables in the cable tray to block the air flowing around those, and then we would encase the whole thing and then paint it off with a mastic that would seal everything off and give you a nice clean job. So what do we do? What does Pure Air do differently than everybody else? We look for, we're first of all very experienced. We've done thousands of rooms. We generally find all of the bypasses and penetrations through our history, that we know where to look, and we look for all the possible penetrations, and we have a lot of tools in our toolkit to do that, even if we miss it because of experience and visual inspection. We'll pick it up in the room integrity test and would find it using that and using smoke tubes or smoke pencils, and we would assure ourselves and you that the job that's been done is actually and good and is the best that it can be for that space, and can document that. And then so that's it for the presentation. If we have any questions, anybody has any questions, we can handle those at this time. Otherwise, I would say thank you for your time, and that's the end of the presentation.